In this video, we will be discussing a very brief introduction to trigonometry. Trigonometry involves the study of the relationship between side lengths and angle measures in right triangles. So up until this point, we've talked about the Pythagorean theorem, we've talked about triples, we've talked about special right triangles, but what happens if we have a right triangle and it's not a special right triangle? Then how do we find some of the missing side lengths or angle measures in that triangle? So that's when we're going to use trigonometry. So in this section, we'll talk very briefly about the three main trig functions that you'll be using and when it is appropriate to use them, how you'll use them. So first, we're just going to talk about the ratios. So there are three ratios for you to keep in mind, and they all are related to a right triangle. So first I'm going to draw this right triangle here, just so we remember that we only use it on right triangles. The first trigonometric function is called sine. And the sine of an angle measure is equal to the ratio of the opposite side over the hypotenuse. So you'll be given some angle measure, and then from that angle measure, you're going to put the side that is opposite it over the hypotenuse of the right triangle. Now the cosine of an angle measure is equal to the adjacent side over the hypotenuse side. So adjacent means the side that is next to that angle. And then finally, the tangent of an angle is equal to the opposite side over the adjacent side. And this is going to make a lot more sense once we get to some actual examples, but for now we're just going to try to memorize these three ratios. So one way to remember it is just to think of SOHCAHTOA. Sine means opposite over hypotenuse. Ka means adjacent, so cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So if you just remember SOHCAHTOA, then you'll have those three ratios memorized. Keep in mind that this is only used with right triangles. And again, this is if you can't find the missing side or angle any other way, then you're going to use trigonometry. So for example, if we look at example 1 here, we're given that this is a right triangle ABC, and it asks us to find the sine of angle A. So basically what that's asking for is a ratio. So here's angle A. I'm going to highlight that in blue. And I'm also going to put my SOHCAHTOA up here at the top so I remember what each trig function means. And it's asking for the sine. Remember, the sine is the opposite side over the hypotenuse side. So you have to look at angle A. And what side is opposite of angle A? That would be the 15. So that's going to go on top of your ratio. Over the hypotenuse side. Well, we know that AC is the hypotenuse, and even though it's not given, we know this is a triple, 8, 15, 17. So the sine of angle A would be 15 over 17. That's your final answer. We're just looking for a ratio. Now we want the cosine of angle A. So cosine is adjacent over hypotenuse. Adjacent would be the side that's next to it. So that would have to be AB, because we know the other side, AC, is the hypotenuse. And adjacent and hypotenuse cannot be the same thing. So cosine of angle A would be 8 over 17. Okay, then finally we're going to look at the tangent of angle C. Now notice they switched angles, so now we have to take a different approach. So I'm going to kind of erase what we have here. And angle C is now at the bottom. So if I want the tangent of angle C, that would be opposite. So the side of opposite of angle C would be 8. And then adjacent would be the 15 because we know that AC is the hypotenuse. So 8 over 15 would be the final answer. Now keep in mind, since these are ratios, they're fractions, always make sure that your final answers are completely reduced. Okay, so now I would like you to try example 2, the same exact way we just did example 1. So go ahead and find the sine, cosine, and tangent of the two angles. Notice that we are only looking at angles x and z. We are not looking at angle y, the right angle. We never use trigonometric functions on the right angle. Why do you think that is? Well, if we think about the right angle here, if we were to say the side opposite of the right angle, that would be xz, which is also the hypotenuse. So we kind of run into a problem where we have opposite and the hypotenuse being the same thing. And then if I said adjacent to the right angle, we would have two options. So that's why we only use trigonometry on the other two angles, because we run into a problem if we try to use it on the right angle. And we shouldn't really need to ever use it on the right angle. We should be able to find everything we need to know from the other two angles. So go ahead and try example 2. Just write out those ratios and then press play when you're ready to check your answers. Go ahead and check your answers to example 2. Again, this was a triple and we had to find the missing side was 9. Check those ratios, make sure you got them all correct. Something that I'd like to point out that hopefully you noticed is what is the relationship between the sines and the cosines of the two angles in the right triangle? So hopefully you notice that when you switch angles, that the sine and the cosine ratios kind of switch. And same thing with the sine and cosine ratios of the other angle. And then something else to keep in mind with the tangent of the two angles is notice that they are just the reciprocal of each other. So that's just something to keep in mind whenever it's asking for the sine or cosine, just in case you were noticing a pattern there. In example 3, we're given isosceles triangle KLM with base LM, and it asks us again to find sine, cosine, and tangent. Now, what's the issue with this diagram? Hopefully you notice that we don't have a right triangle, and I said we only use trigonometry on right triangles, so we need to think about how can we get a right triangle. I would draw then the altitude from angle K to get two right triangles. And we know that in an isosceles triangle, the altitude is also the median, so that would divide the base in half, so each of those segments would be 10. Now, when you go to find the sine, cosine, and tangent, you really only need to look at one of the right triangles, depending on which angle. So for the first two, you only have to look at the triangle on the right. And then to find the tangent of angle L, look at the triangle just on the left-hand side. So go ahead and see if you can find the sine, cosine, and tangent, and then press play when you're ready to check your answers. Alrighty, so go ahead and check those three answers. Notice that my answers were not completely reduced, so I had to reduce them in order to get the final answer, so don't forget to do that when you're doing these problems. You also had to find the length of the altitude since it was a 5, 12, 13 triple. Now this next example, example 4, is slightly different because now it's asking us to name each missing angle. So it's giving us a trigonometric ratio and then it's asking us to determine what angle they are talking about. Now I already mentioned that we're never going to use trigonometry on the right angle. So immediately we can kind of eliminate angle N. So for those three answers, it's either going to be angle O or angle M, depending on the ratio. So the first trig function is a tangent problem. And we know that tangent is the opposite over adjacent. So this means that the 20 would be opposite the angle, and then the 21 would be next to the angle. So what angle has 20 opposite and 21 next to it? Hopefully you're saying angle O. So go ahead and try the next two examples and see if you can find which angle it's talking about, either angle O or angle M. Alright, so check your answers. The next two should be angle M because the sine is opposite over hypotenuse and the cosine is adjacent over the hypotenuse. Now this last example involves one of our special right triangles. This is a 30, 60, 90, and it's asking us to find the sine of the 30-degree angle. Well, we have to recall back from 9.7, what is across from 30? So 30 across from the 30 is x, across from the 60 is x times the square root of 3, and then across from the 90 is 2x. So when it asks for the sine, remember the sine is opposite over hypotenuse. So opposite of the 30 would be x, the hypotenuse would be 2x, and then I always want to reduce. The x's will cancel out, so since nothing's left on top, there's technically a 1 up there, over 2. The sine of 60 would be opposite, so x times the square root of 3 over the hypotenuse, 2x. Again, the x's are going to cancel out, and you're left with the square root of 3 over 2 as your ratio. Now, the tangent of 60 is opposite over adjacent. So opposite would be x, square root of 3, over adjacent, which is x. The x's cancel out. Now, we wouldn't just leave our answer as the square root of 3 because technically that's not a ratio. So you do have to keep it over 1 since we're asking for trigonometric ratios. So hopefully this gives you a better understanding of the sine, cosine, and tangent, when to use them, and how to set up the ratios.